Okay, so what we're going to do here is we're just going to look and see if we can prove some identities that may or may not be true, well, or may or may not be ones that we already know. So we're just going to use what they're giving us. They're giving us the left-hand side, and they want us to come up with the right-hand side of this identity. So for the first one here, we're going to have the sine of pi over 2 plus theta equals, so this is kind of like the complements, except the complements is where it's pi over 2 minus theta. This is pi over 2 plus theta. So you're just going to add 90 to your angle. So this is a sine, and it's a sum. So we're going to have the sine of pi over 2 times the cosine of theta, and then that's going to be plus the cosine of pi over 2 times the sine of theta. All right, so we just do the math. Well, what is the sine of pi over 2? Well, the sine of pi over 2 is 1. We don't know the cosine of theta, so we've got the cosine of theta. Plus, what's the cosine of pi over 2? Well, the cosine of pi over 2 is 0 times the sine of theta. So when you do that, 0 times the sine of theta cancels out. So this actually equals the cosine of theta. Okay? So what's that saying? Well, that's saying that if we had pi over 6 and we added pi over 2 to it, that it would equal the cosine of pi over 6. And it does. It's crazy. All right, next one, we have the cosine of theta plus pi. So when we do this particular problem, we know what we're trying to find what that equals. So we've got cosine theta, cosine pi, minus sine theta, sine pi. Well, the cosine of theta we don't know. We know the cosine of pi is -1. So cosine theta times -1 minus the sine of theta times the sine of pi, which is 0. So this just all equals negative cosine theta. And isn't that our half-turn theorem? So it's just a way that you can use these identities to come up with more identities.